Half of everything we thought we knew about the universe was literally hiding in plain sight. And scientists just found it using some of the most powerful cosmic explosions ever detected. For decades, astronomers have been scratching their heads over a mind-bending puzzle. Where exactly is most of the universe's normal matter? We're not talking about the mysterious dark matter that makes up most of the cosmos. We're talking about the regular, everyday matter that forms stars, planets, and yes, even you and me. And here's the kicker. Roughly half of it was completely missing from our cosmic accounting books. But here's where it gets controversial. Some scientists wondered if our fundamental understanding of the universe might be wrong. Were we missing something basic about how matter behaves on cosmic scales? The answer, as it turns out, is far more fascinating than anyone imagined. When the universe plays hide and seek. Let's get one thing straight. The cosmos is dominated by an invisible substance called dark matter, which we can only detect through its gravitational effects on visible objects. This ghostly material makes up about 84% of all matter in existence. The remaining 16%? That's what scientists call ordinary or baryonic matter, the familiar stuff made of atoms that actually emits light and can be directly observed. Now here's where things get weird. Even though this ordinary matter represents just a small fraction of the universe's total mass, astronomers could only account for about half of it. The rest seem to have vanished without a trace, spread so thinly across the vast emptiness between galaxies that it became virtually undetectable using traditional methods. This wasn't just an academic curiosity. It was a fundamental gap in our understanding of cosmic structure and evolution. And this is the part most people miss. If we can't even locate the matter we can theoretically see, how can we trust our models of how the universe works? Cosmic lighthouses reveal hidden secrets. Enter fast radio bursts, or FRBs, some of the most enigmatic and powerful phenomena in the known universe. These cosmic lighthouses produce incredibly brief but intense flashes of radio energy that can outshine entire galaxies for mere milliseconds before disappearing forever. A groundbreaking study published in Nature Astronomy has finally cracked the case of the missing matter, using these mysterious bursts as cosmic detectives. The research team, led by Liam Connor from Harvard University and the Center for Astrophysics, along with collaborators from Caltech, accomplished what seemed impossible. They weighed the invisible fog of matter floating between galaxies. Think of FRBs as powerful flashlights shining through a cosmic mist, explains Connor, who spearheaded much of this work while at Caltech. By carefully measuring how that light gets distorted as it travels through space, we can actually weigh the mist itself, even when it's far too faint for us to see directly. But here's what makes this discovery particularly intriguing. The method works almost like cosmic archaeology, allowing scientists to trace the fingerprints of matter that's been hiding for billions of years. Breaking records while breaking barriers. The research team didn't just stumble upon this discovery. They meticulously analyzed 69 different fast radio bursts, each originating from distances spanning an almost incomprehensible range. The closest burst traveled roughly 11.74 million light-years to reach Earth, while the most distant one, designated FRB 2023-0521b, holds the record as the farthest FRB ever detected, having journeyed an astounding 9.1 billion light-years across space and time. And this is the part that might surprise you. While over 1,000 FRBs have been discovered to date, only about 100 have been successfully traced back to their source galaxies. This particular subset, where both the origin point and distance are precisely known, proved absolutely crucial for the team's measurements. The researchers relied heavily on the Deep Synoptic Array Company 110, an impressive network of 110 radio telescopes strategically positioned at Caltech's Owen Valley Radio Observatory near Bishop, California. This purpose-built FRB hunting system detected 39 of the 69 bursts used in the analysis. Additional observations came from world-class facilities, including the W.M. Keck Observatory in Hawaii and Palomar Observatory near San Diego, while the remaining 30 FRBs were contributed by telescopes around the globe, particularly the Australian Square Kilometre Array Pathfinder. Shadows in the cosmic web. Now, here's where the science gets truly elegant. The fast radio bursts themselves weren't the main attraction. They were simply the tools needed to reveal something far more significant. As these intense radio waves travel across billions of light-years of space, they encounter the thin soup of matter floating between galaxies. And this encounter leaves a distinctive signature. The radio waves become dispersed, spreading out into different wavelengths, much like a prism breaks white light into a rainbow spectrum. The degree of this dispersion directly correlates with the amount of matter the radio waves encountered during their cosmic journey. Imagine trying to study a person by examining only their shadow, explains Vikram Ravi, assistant professor of astronomy at Caltech and study co-author. You might not see all the details, but you can still determine that someone is there and get a rough idea of their size and shape. That's essentially what we're doing with the universe's missing matter. This technique represents a revolutionary approach to cosmic archaeology, allowing scientists to map the invisible scaffolding that connects galaxies across the universe. The universe's hidden architecture revealed. The results were nothing short of remarkable, and they confirmed what computer simulations had long predicted, but never proven observationally. The analysis revealed that approximately 76% of the universe's ordinary matter resides in the vast spaces between galaxies, forming what cosmologists call the intergalactic medium. About 15% exists within the extended halos that surround individual galaxies, while the remaining portion is concentrated within galaxies themselves, either in stars or in cold gas clouds. This distribution pattern aligns perfectly with sophisticated cosmological models that simulate how matter should be organized on the largest scales. However, until now, these predictions remained largely theoretical, impressive computer simulations with no direct observational backing. But here's where it gets controversial. This discovery has profound implications that extend far beyond simply finding missing matter. The precise distribution of ordinary matter throughout the universe directly influences our understanding of subatomic particles called neutrinos, which, according to the standard model of physics, should be massless. Yet experimental evidence suggests they do have an incredibly tiny mass. The degree to which ordinary matter clusters throughout space affects neutrino behavior, and knowing the exact mass of these ghostly particles could potentially reveal new physics beyond our current theoretical framework. Are we on the verge of discovering something that could revolutionize our understanding of fundamental physics? A new era of cosmic discovery. According to Ravi, this breakthrough represents just the opening chapter in what promises to be an exciting new field of FRB cosmology. The future looks even more promising with Caltech's planned DSA 2000 radio telescope, currently in development for installation in Nevada's desert landscape. This next-generation facility will be capable of detecting and precisely localizing up to 10,000 fast radio bursts annually. A dramatic increase that will transform these cosmic phenomena from rare curiosities into routine tools for probing the universe's deepest secrets. The implications extend far beyond academic curiosity. Understanding how matter is distributed throughout the cosmos helps explain how galaxies form and evolve, how large-scale structures develop over billions of years, and potentially how the laws of physics themselves operate under the most extreme conditions imaginable. The bigger picture. This research, funded by the National Science Foundation and involving a large team of scientists from multiple institutions, demonstrates how cutting-edge technology can solve puzzles that have perplexed astronomers for decades. The study's publication in Nature Astronomy marks a significant milestone in our quest to understand the universe's true structure. But here's what really makes this discovery fascinating. It shows that even in an age when we can image black holes and detect gravitational waves, the universe still holds fundamental surprises. The missing matter wasn't hiding in some exotic location. It was scattered throughout the space we thought was empty, invisible to our instruments, but detectable through its subtle influence on radio waves from the most distant corners of the cosmos. What other cosmic mysteries might we solve by learning to see the universe in entirely new ways? And perhaps more intriguingly, if half of the ordinary matter in the universe was hiding in plain sight, what else might we be missing in our cosmic neighborhood? The discovery raises as many questions as it answers, opening new avenues for exploration that could reshape our understanding of the cosmos itself. What do you think? Does this discovery make you more confident in our scientific models of the universe? Or does it highlight how much we still don't know about the cosmic environment we inhabit? The debate continues, and the implications keep expanding with each new fast radio burst we detect.